Good afternoon, everybody. Today we are going to be talking about 7-5, the last of the exponent rules. So far we've seen multiplication, we've seen raising a power to a power, and today we're going to see division. The good thing is that there's a common strand to all of these. When you are multiplying the same bases, for example, x to the n times x to the m, you keep the base and add the exponents. Fair enough. When you raise a power, x to the n, to a power m, you keep the base and multiply the exponents. Well, today we're going to stay in that same rhythm. When you divide the same bases together, okay, whether the bases are numbers or variables, you simply keep the same base. Keep the same base again. So you're always keeping the same base, my man. And subtract the exponents this time. Then simplify the numerical values accordingly. I'm going to show you the real way to do it by subtracting, but I'm also going to show you the Mr. Morrow way of simplifying it a lot easier without using all these negatives. You'll see what I mean in a little bit. The rule, the real power law is when you divide the same base, a to the m divided by a to the n, you keep the base a and you subtract the exponents, m minus n. Whatever the value of n is, okay, even if it's a negative, it's m minus the negative n. When I have a quotient and I raise a quotient to a power, just like when I raise a product to a power, I have to distribute the exponent to every single exponent inside of the parentheses. So a to the m divided by a to the n will equal a to the mp divided by a to the np. Does that make sense? Okay. Now, let me show you guys the real way to do it, and then I'll show you my trick. Yes, sir. It's the bottom number. I said a to the m divided by a to the n. It's the m minus n. It's the top exponent minus the denominator's exponent. Thank you, sir. For example, let me show you the real way, and then I'm going to show you my way. The real true way to do x to the 8 divided by x to the third is x to the 8 minus 3, which is x to the 5th. Right? That makes sense, right, guys? Now, here's my issue with this type of problem. What if I had x to the 8 over x to the negative 3? What would the answer be here? Okay. Did everyone catch why it would be x to the 11th? Because it's going to be x to the 8th minus a negative 3, which will be x to the 11th. Now, I'm going to be honest with you. A lot of you guys are going to mess up here. Not because you can't do it, but because you're not going to practice the skills enough, and you're going to get confused. If you don't get confused, God bless you, you can do it, great, awesome. Let me show you my way. Let me show you my way. What I would first do for me is, hold on, let me go back to the original one here. How many x's do I have up here, guys? 8, right? Whoever said 1, no, that's x to the 8th power. There's 8 x's. X times x, 3, 4, 5, 6, 7, 8 x's over 1, 2, 3. That's what I have here, right, if I were to expand this, correct? All right, check it out. What's anything divided by itself? Cancels. So, boom, boom, boom. I've got x to the 5th power. Does everyone see that? That's what I'm doing. Bless you. That's what I'm doing without actually writing out all of the x's. What I do is as follows. How many x's are in the numerator here? How many x's are in the denominator here? Okay. Can't I take 3 x's from here and 3 from here? I'm left with x to the 5th in the numerator. I'm done. Yes. I'm going to go. Relax. Now, What if it's x to the 8th over x to the negative 3rd, like I had said before? Whenever you have a negative exponent, make all negative exponents positive first, comma, then simplify. So for this particular case, I've got x to the negative 3 here, right? Hello? How do I make that a positive? I bring it up. So wouldn't I have x to the 8th now times x to the 3rd? What does x to the 8th times x to the 3rd equal? X to the 11th, and I don't have to worry about any of the negatives. Does that make sense, guys? Let's practice this skill then. Let's practice this skill. Let me go ahead and take this. Whoa, no. Let me take. Oh, okay, here we go. Well, you guys got this part, right? I'm going to get rid of this. Goodbye. Okay. Let's see what we got here. All right, guys, how many W's do I have in the numerator? How many W's do I have in the denominator? The real official way would be W to the 4 minus 7, which equals W to the negative 3, which equals 1 over W cubed. Or, you could do it Morrow's way. Take 4 W's away from the numerator, leaving me with 1. Take 4 from the denominator, leaving me with 3. Boom, done. Didn't have to worry about any negatives. Does that make sense, gentlemen? It's a lot easier in my opinion. Next, whenever I raise a power to a power, whether it's a power by itself, a product, or a quotient, I'm going to distribute that exponent to every single exponent inside of the parentheses. So in this case, this is going to equal x to the negative 6 over y to the negative 12. But I never can have negative exponents, so how do I make these positive, sir? That's exactly right. You flip them both. So this will become y to the 12 because I went from the denominator to the numerator, over x to the 6 because I went from the numerator to the denominator. Does that make sense? Okay, next. 3x cubed divided by 2y to the 5th raised to the 3rd power. When I raise a power to a power, I distribute that power to every single exponent. Please remember, guys, that there's an invisible 1 exponent for the 3 and an invisible 1 exponent for the 2. So 3 gets distributed to that, to the exponent of 1, to the exponent of 3, to the exponent of 1, to the exponent of 5. So this is going to equal 3 cubed x to the 9th over 2 cubed y to the 15th, which equals 27 x to the 9th over 8 y to the 15th. Does that make sense, gentlemen? Okay, so let's practice then. May I? Okay, thank you. All right, you guys have this all on your paper, so please don't tell me I don't know what it is. Okay, A. Right, yes, sir. If it was a 24 on the top, sir, in this example, if it was 24 x to the 9th over 8 y to the 15th, of course, sir, like always, we reduce. And that would be 3x to the 9th y to the 15th. Before I move on to the next slide, are there any other questions, please? Are you sure? Okay, thank you. Thank you for that question, sir. Okay, I have y to the 8th divided by y squared. Make it easy. Get rid of the 2 in the denominator, 2 from the top, so I'm left with y to the 6 in the top, correct? Okay, what do I do for b here? I've got h to the negative 5th divided by h to the 4th. What's the first thing I told you to do? Yes, sir. Absolutely. You make that h to the negative 5th a positive, and you do that by bringing it down to the denominator. So I'm going to have 1 over h to the 4th, because I don't mess with that guy because he's positive, so I leave him alone, times h to the 5th. So this should be 1 over h to the 9th. Because when you multiply the same base, you keep the base and add the exponents. Yes, sir. So anyways, for C, I've got x to the 5th, y to the negative 3rd, w to the 7th, divided by x to the 3rd, y to the negative 5th, w to the 12th. Okay, what do I do here first, sir? Bring that guy down, bring that guy up. Let's make them all positive first. Trust me, guys. I know it may seem like you're like, wait, why is he making us do all this? It makes it so much easier. If not, you would have to do y to the negative 3 minus a negative 5. You guys sure you'll be able to handle all those negatives? Some of you will get confused because it's a matter of practice. So please, make them all positive, just like my boy said. So this will now become x to the 5th, y to the 5th, because I brought this guy up, w to the 7th. I do not touch any positive exponents. Then I have x cubed. I bring down the y to the negative 3 as a y cubed. And then I have w to the 12th because I don't mess with positive exponents. Does everyone see what I just did there, gentlemen? Now it's Mickey Mouse. Get rid of 3 x's from the denominator. Get rid of 3 from the numerator, so I've got an x squared. You with me? I've got 3 y's in the denominator. Get rid of 3 y's from the numerator. I'm left with y squared up in the numerator. You with me? Get rid of 7 w's from the numerator. Get rid of 7 from the denominator. I'm left with w to the 5th power. Do you see how easy that flows? Does that make sense to you guys? Do you like that better than the whole subtracting thing? Okay, and then don't do it. Why don't you like it though? Just out of curiosity. So basically you're saying this then get ready for the reality of your life if you don't want to do it that way. And this is going to be x to the 5 minus 3, y to the negative 3 minus a negative 5, w to the 7 minus 12. And then this is going to be x squared, y2 squared, w to the negative 5. Then that's going to be x squared, y squared over w to the 5th. There is nothing wrong with that. If you like that, God bless you. I'm not going to penalize you for doing it the way you like to do it. I'm just giving you guys an alternative. But if that's the way you want to work it, that's fine. God bless you. In fact, I'll do D both ways. This will be m to the 4th minus a negative 7, n cubed minus 9. So that's m to the 11th, n to the negative 6, which equals m to the 11th over n to the 6th. Done. Or you could have done this. Bring the 7 up to the top. So m to the 4th, m to the 7th, n to the 3rd over n to the 9th. M to the 4th times m to the 7th is m to the 11th. Take 3 away from here, take 3 away from the denominator, n to the 6th. Still going to get the same exact answer. I don't care which one you guys use, but I will say this. Choose one. Choose one method that you like and stick to it forever. Forever. Is that fair? Okay. Let us continue, please. I'm going to erase this one now. All right. I've got here, I'm going to distribute this 2 to every single exponent in the parentheses. So I got 3 squared, y to the 6th, x to the 10th over x squared. That's going to equal 9, y to the 6th, x to the 8th. Why? Took 2 from here, took 2 from there, I'm left with 8. Does that make sense, boys? Yes, sir. Ah, wait. Wrong. I was testing you. No, just kidding. 3 squared, y to the 6th, x to the 10th, ding dong, x to the 4th. Duh. 9, y to the 6th, take 4 from the bottom, so I should have x to the 6th left over. Sorry, my bad. I should pay attention. Let's do G. That's a to the 20th, b to the 15, over a to the negative 25. How do we make this negatives positive? Bring it up. So I'm going to get a to the 25, a to the 20 times b to the 15th, which equals a to the 45, b to the 15th. Does that make sense? Let's get rid of this. Okay, this is a good one. This is going to be c to the negative 6, a to the negative 12, b to the negative 15, over a to the 12, b to the 6th. What do you want to do here? No, you can't cross anything out because I have negative exponents. If you guys think, oh, negative 12 plus 12, that cancels. That is wrong. That's why I say, guys, stick to one method and only one method. If you're going to do it the real, true way, it would be c to the negative 6, a to the negative 12 minus 12, b to the negative 15 minus 6. That's going to be then 1 over c to the 6th, a to the 24th, b to the 21. That's one way to do it. That's the real traditional exponent law way to do it. Because when you divide exponents with the same bases, you subtract them. So a to the negative 12 divided by a to the 12 is not 1. They're not the same exponents. Or you can do it the way I like to do it. Which I don't care which way you do it. I'm going to bring all of these down to the bottom and make them positive. So I'm going to have 1 over a to the 12th, c to the 6th, a to the 12th, b to the 6th, b to the 15, which equals 1 over a to the 24th, c to the 6th, b to the 21. Does that make sense, gentlemen? Promise. Okay. Now this last one, let's just do this in green. This is going to be 2 cubed, x to the 6th, y to the 9th, over 3 cubed, x to the 12th, y to the negative 18. Me personally, I'm going to move that negative 18 exponent of y to the top. So I'm going to get 8, x to the 6th, y to the 9th, y to the 18, over 27, x to the 12th. Now that everything is positive, now I just cancel. 8 and 27 cannot reduce, so I have my 8 and 27. 6x to the top takes 6 from the bottom. I'm going to have 6x to the 6th in the denominator. Y to the 9th times y to the 18th. When you multiply the same base, you keep the base at the exponents. That's y to the 27th. Does that make sense, gentlemen? You promise? Okay. May I continue? Okay. Putting it all together. All the laws of exponents. I think I was pretty nice in doing this, just as a reminder for you guys. A to the m times a to the n is a to the n plus n. When you multiply the same base, you add the exponents. When you raise a power to a power, a to the m raised to the n power is a to the mn power. Keep the base, multiply the exponents. When I have ab raised to the n power, I'm going to distribute that outside exponent to every exponent inside. Remember, when a number or variable is not showing an exponent, there's an invisible exponent of 1. So ab to the n power is going to be a to the n times b to the n. A divided by b to the n power, you still are raising a power to a power, so you're going to distribute that power to every single exponent inside of the parentheses. So that's a to the n divided by b to the n. Last but not least, what we just learned today, division. A to the m divided by a to the n. When you divide the same base, you keep the base, subtract the exponent. So not only is it there visually, but it's here verbally. When you multiply the same base, add exponents. When you raise a power to a power, multiply exponents. When you divide the same base, subtract exponents. Does that make sense? Okay. Let's do this then. Let's put it all together. Okay. My boy, number 1. Yes, x to the second times x to the fifth is x to the seventh. When you multiply the same base, you keep the base and add the exponents. Great, sir. Next. What we got here? What we got? What we got? What we got here? Yes, sir. Negative 4 in parentheses to the negative 1. Good. X to the negative 8. Good. 2 to the negative 1. X to the negative 3. Okay. Now what do I do with that? You're going to bring down all of this, right? You're going to bring it down. And what are you going to do with all of this? Bring it up. Good man. So what would that look like, my brother? 2x cubed. Good man. Over? Negative 4, because negative 4 to the first power is negative 4. X to the 8th. And then that's going to reduce to negative 1/2 x to the 5th, bro. Right? Let's go ahead and show you guys that without scrunching it in so much. You've got here 2x cubed over negative 4 x to the 8th. Like I was saying, so this is negative 1/2, okay? I got 3 up here, I take 3 from here, and I've got x to the 5th. So on a negative 8 minus a negative 3 is x to the negative 5. X to the negative 5 goes down to the denominator. Trust me, I got it. Thank you, sir. Yes, sir. Okay, talk to me. What do I do here? A to the negative 2 times b to the negative 2. Wrong. Over 5 to the negative 2. You distribute that to every single exponent, my brother. Okay? Now, how do I make these exponents positive? You flip them. So this guy goes up. That's going to be 5 squared, which is 25. And these bad boys go down. A squared, b squared. Very good. Awesome. Well done. Does that make sense? Okay, next. Okay, here. What do I got here? Okay, 81. W to the 6th, y to the 7th, over 3 squared, which is 9, w to the negative 4, and y squared. Is everyone with me so far? Are you sure, guys? Okay. What's 81 divided by 9? 81 divided by 9. 9. Now, am I not going to bring up that negative? So when I bring it up, am I not going to be multiplying it to w to the 6th? So what would that be? W to the 10th up here at the top. And then I've got 2 y's in the denominator. Bless you. Bless you. Take away 2 from here, so that's y to the 5th. So I got y to the 5th over 1. Nothing in the denominator. I do not have to put it over 1. No, sir. I was just for teaching purposes. But no, you do not have to put it over 1, sir. Thank you, sir. Ah, these is my good favorites now. This is where we get good. Okay. So just, instead of complaining about it, like I just heard a few of you complain, just go ahead and use logic. Do it. You know how to do this. Sir, what you got?
I distributed the 2.
Yes. Okay, so it's going to be 25, right? 5 squared is 25. X to the 6th. Y to the 12th. Times. Correct. X to the negative 8. Y to the 16th. Over y to the negative 12th.
And then from there, you flip the negatives.
I would definitely. Okay, from here, guys, you're going to have 25 x to the 6th, y to the 12th, times, bring that up, and bring the x down. So I've got y to the 12th times y to the 16th, so that's y to the 28th. over x to the 8. And now cancel, 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 cancel. You're going to have 25. Y to the 12 times y to the 28th is y to the 40. I've got 6x's in the numerator. Take 6 from the denominator here. And I'm left with x squared. Get used to it, guys, because that's how I'm going to make it on the quizzes and the tests. I want to make it as complicated as possible. I want to make sure you understand this, because it's easy if you follow directions. Did you get that answer, my brother?
Yeah.
Good job.
I stopped though at
I'm proud of you.
to the y to the 28 over x to the 8.
I'm very proud of you. Okay, what's this one going to be here? 30y to the 4th divided by negative 5y to the 8th. Okay, 30 divided by negative 5 is negative 6 up at the top. Well, y to the negative 4 would equal y to the 4th in the denominator, right? So remember that, guys. You cannot have negative exponents. You have 4y's in the numerator, take 4 from the denominator. Why are you guys even bothering with the negatives? Every time you guys have tried the negative route, you're getting them wrong. Because you're not strong with negatives. If you were strong with negatives, I wouldn't be even teaching you my trick. But you're not. I'm sorry, guys. So either get strong with negatives and do it the official way, which would be like this. That'd be negative 6 y to the negative 4th, which equals negative 6 over y to the 4th. Or learn how to cancel it. But you got to learn one way. It's going to be 6. Those 4 go bye-bye, and you're left with 4 down here. Either or. I don't care. I'm not going to penalize you for doing it one way or the other. But you will get it marked wrong if you do not do it correctly. Okay. I don't have much time, so let's see. I got to fly through this one. This is going to be 2 cubed, which is 8. X cubed, y to the 9th, z to the negative 6, over x to the 12th, y to the 6th, z to the negative 9, times x to the negative 4, y to the negative 10, z to the negative 6, over 16, x to the 12th, y to the 6th, and z to the negative 8th. That's the first step here. Okay? Let me just rearrange this. Actually, let me move this for now. Okay, now from here, I'm going to make everything negative in this first one. So the only guys that I got to flip is this guy goes up here, and this guy goes down here, correct? So this is 8, x3 up here, take 3 from there, I got x to the 9th down here. 6y's here, take 6 from there, I got y cubed up there. Then this is z to the 9th over z to the 6th. So I've got 8y cubed, z cubed over x to the 9th. Because 6 from here, 6 from there, boom, done. Now, this guy. This is going to be the z to the, this negative z goes up. Then down at the bottom you have this, the 16, x to the 4th, which you brought down, x to the 12th, which was there already, y to the 10th, which you brought down, and y to the 6th, which was there already. Wait. So I've got z to the 8th over 16, x to the 16, y to the 16. Now pay attention to this, because this is easy. Just got to pay attention. That goes to 1, that goes to 2, because I just divided. Simplified. I've got 3y's here. I've got 16y's here. So I've got 13y's left over in the denominator. Z to the 11th, z to the 3rd times z to the 8th is z to the 11th. And x to the 9th times x to the 16th is x to the 25th. There are 3 more in your PDF that we have not completed. Okay? That would be the last 3. I think it's H, I, and J. I suggest you do those tonight for homework, in addition to your regular homework. Thank you very much. May God bless you. Have a great day.